All right, so in this first problem, we have a question is how tall? Well, according to the National Center for Health Statistics, the distribution of heights for 15-year-old males is a mean of 170 centimeters and a standard deviation of 7.5 centimeters. Paul is 15 years old and 179 centimeters tall. So part A, asking for the z-score corresponding to Paul's height and then to explain what this means. So let's first find the z-score. And let's call it the z-score. It's equal to the distance that the observation value is. So x is from the mean, so x minus mu, over the standard deviation of the distribution. In this case, our x value for Paul, so observation value is 179. So z would be 179 minus the mean, which is 170, over the standard deviation, which is 7.5. We would have negative 9 over 7 point, or 9 over 7.5. That would be 1.2. Okay, so the z-score is 1.2. So now let's break down what that means in the context of this problem. Let me draw a picture of what we're looking at. So remember, we're talking about how far Paul's, height it deviates from the mean, relatively speaking. So so in general, a normal distribution, a standard normal distribution, has a mean of 0. These are z-scores, so the mean of 0 and standard deviation of 1. So remember that z-scores are positive to the right of 0 and negative to the left of 0. So if he's 1.2 standard deviations, his value corresponds to a z-score of 1.2. That means he's 1.2 standard deviations above the mean. So let's say let's just again approximate 1.2 would be to the right of 0. And so then all of this area, once we calculate it, corresponds to the percent of the population of 15-year-old boys that Paul is taller. So in this problem, we for part A, we can simply say that Paul's height is 1.2 standard deviations above the average, or the mean height for boys his age. All right, now let's look at part B. So part B says that Paul's height puts him at the 85 percentile among 15-year-old boys. Explain what this means to someone who knows no statistics. So I actually already drew what the answer, corresponding to. So that 85 percentile, that means that he's above or taller than 85% of the 15-year-old males. He's greater than, his z-score is greater than 85% of all the individuals in the same distribution. So in other words, in a graph, visually, this shaded region would correspond to an area of 0.85, because remember the total area has to be 1 on our normal curve. So we just have to say something like that. So Paul is taller than 85% of boys his age. All right, let's look at problem 2 now. Problem 2. So we have a graph that we're gonna have to use. So here we got that. That's pronounced Kasi. Interesting name. It's Kasi. You ask your students how much time they had spent using the computer during the previous week. The following figure shows the cumulative relative frequency graph for students' responses. Part A. At what percentile does a student who used her computer for 7 hours last week fall? So let's go over how we read this. And let me I'm going to grab a straight edge, a ruler. This will be as precise as possible. So essentially, using the hours per week as the horizontal values and the vertical values or the vertical axis is going to correspond to the cumulative relative frequency. So basically, the total percentage of individuals less than or equal to that point. So let's show exactly what we mean for part A. So someone who used her computer for 7 hours last week, this shows the hours per week. We're looking at a value, 1/3 between 6 and 9. That'll be 7, that'll be 8. 7 will be right about there. And you want to see where this would intersect this graph at. So to be precise, you want to draw a perpendicular line as good as accurate as you can. This is why I have this. So I'm going to draw a perpendicular line upwards. And I'm going to essentially find where this point corresponds to the cumulative relative frequency percentage. So I'm going to draw a horizontal line through this point, going through this axis. So again, I want to draw as perpendicular as I can to be accurate. Something like that. So I'm trying to find this value here. So what this value is, it's a little less than 60, you can see. A little less than 60. I think the actual value is 58. 58, but I'm like, if I was checking the students, answer on a test, as long as they show this work and their answer makes sense to their work, maybe they put 57 or 55 so you drew a line a little crooked, I would still give them credit. So I'm going to assume that most teachers will grade you this way. So just make sure you show like how you're getting your value, so that they don't, so your professor or teacher doesn't dock you down if you're off by a little bit. Okay, so part A will be 58 percentile. Now, part B is asking, estimate the interquartile range, IQR, from the graph. Now let's remember what the IQR or interquartile range is. And we're talking about basically from the 25 percentile to the 75 percentile. Remember the quarters. First quarter to the third quarter. Q1 to Q3. So we kind of go backward. We should go backwards from this axis and look at what the values that these percentages correspond to the hours per week. So let's try again, draw this as accurate as we can. So I would 25 halfway between 30, between 20 and 30, so 25, and 75 halfway between 70 and 80, something like that. And then draw a horizontal line perpendicular or parallel to the x-axis as best as I can. So I'll control, let's see what I got. Something like that. And then my 75 percentile line. Again, trying to draw this perpendicular as I can. Something like that. And then I try to match up where this intersects the graph. So I'm looking at, this point and this point. And then I go and draw a perpendicular vertical line and see where it would go through the x-axis. So kind of going backwards from part A. Dropping that there about, doing my best. That would be right about 11. So here, again, the answer, I think, is 2.5, and that looks about right. And this is 11. Now, there's two ways to interpret the answer, because I noticed from the way they graded AP exams, the IQR is technically Q3 minus Q1. So if a teacher wanted to be strict for part B, if you wrote your answers IQR is equal to, IQR is 2.5 to 11, that technically would be wrong based on like the formal definition and stats books. Sometimes I'll give students most of the credit, it just depends on their work. Again, always show as much work as you can, but technically the answer has to be a number. So basically what this number is equal to. So the IQR in this case would be 8.5. And the context 8.5 hours per week. Basically telling you how much the 25 percentile and the 75 percentile range, like what's the difference between those two. So make sure you pay attention to that little detail because again, some teachers or some professors are more strict than others.